Yeah, it can hear. So guys, please don't swear or anything. I am recording my mic while I'm taking this knowledge check. No. All right. 800 minus 771.1. Borrow 799, 10, 9, 8, 2, 28.9 calories will get her to 800. I could, but I like to be sure so I don't make a mistake. Write that as a decimal. 19 divided by 20 would be 90.95. I know that because it takes 20 nickels to make $1. Yep. Next three multiples of 7 will be 28, 35, 42. $30. 0.7 would be 70%. 432 would be 0.432 as a decimal because you times it by 100, move the decimal place twice to the right. Distributive property, it's going to be 20 divided by 5 is 4u. 60 divided by 4 is 15, so 4u minus 15. X-intercepts is when the y equals 0. Y-intercepts when the x equals 0. So to find the x-intercept, I'll make y 0. I get 2x equals 4. Divide both sides by 2. X equals 2. That's my x-intercept. That's when the line crosses the x. Y-intercept, I make the x 0. It's 4. Y equals negative. Oh, that's a negative 2. My bad, I didn't say negative. Divide by 4. Y equals negative 1. So the x-intercept is 2, and the y-intercept is negative 1. Oh, negative 2. I almost made a mistake. Yes. Like -1, -2, -3? Yes. Yes. 0 is a placeholder. Substitution. So I know what x is. I'll plug it in for x. I get 4 times the quantity 2y plus 2 plus 3y equals 19. I will solve that for y by distributing. Get 8y plus 8 plus 3y equals 19. Combine like terms. 11y plus 8 equals 19. Minus 8 divided by 11. Y equals 1. If I know y equals 1, I'll go back to my first equation, plug in 1 for y, and get 2 times 1 is 2, plus 2 is 4. So x is 4 and y is 1. That is the point where those two lines will meet, intersect. Here is a system of equations. This relates to the last problem I just did. To graph them, I need to know the y-intercept and the slope. The slope for the first equation is 1 because it's an x. The y-intercept is -5. That's where the line crosses the y-axis when x is 0. For the second one, it's -3 for the slope and +3 for the y-intercept. So I will plot my first one by putting a point at -5. Angelica, this is what you were doing. And then the slope is 1, so I go up 1, and over 1 for the second. So then I'll draw that line right away. For the second line, I will plot a point at the y-intercept, which is +3. This is the y-axis. And then -3 means go down 3 to the right 1. And that will be a boom. And then the point where they meet is right there. That is 2, -3. That is the solution for this system of equations. That's the line where they intersect. Yeah, that's what an ordered pair is. Solving inequalities is like solving an equation. You have to do what you do to the same side. This is going to be easy. Also add 3v to both sides. Get -7 greater than 5v plus 8 minus 8 on both sides. Get -15 greater than 5v. Yep. Divide by 5 on both sides. And -3 is greater than v, or v is less than -3, which means all the answers that work would be -4, -5, etc. V is less than -3. Parabolas, I would do this by using function notation, plot the points. I know if I put 0 in for x, I would get a 1. If I put a 1 in for x, I would get 2, because 1 squared is 1 plus 1 is 2. If I put a -1 in, I would get the same point because parabolas are symmetric. If I put a 2 in, I get 2 squared is 4 plus 1 is 5, and it's symmetric, so I get 1 there. and that should be enough, and I'm good. That's my quadratic function. It makes a parabola. Okay, so to multiply exponents, this is the product property. You add the exponents, so it would be 1/2 plus 4/7. I cannot add that as the way it is, so I need to get common denominators. I'll use 14 as my common denominator because I know that 14 is the least common denominator between those two. 2 times 7 is 14, so 1 times 7 is 7. 4 times 2 is 8, so I get W is 15 over 14. W to the 15th over 14th power. That's ugly. I don't like that, but it is what it is. Loans. What do I do here? Is this PERT? I think this is PERT. So PERT is principal equals E to the RT. I might get this one wrong. So the rate is 16%, so that's 0.16. It's quarterly, so that's 4 times a year. Find the amount after 8 years. So I have to do 4 times 8, so that's 32 payments. So it's going to be 0.16 times 32 raised to the, is it to the E? Is this PERT? I don't know if it's PERT. Oh, I'm going to get this wrong. Because principal equals, no, because that's total. So I'm just going to do 2. So 2,000 is the principal. It's the start. I need to go E to the 0.16 times 32 power. So where's my calculator at? 0.16 times 32 is 512. So I got to do E. Where's my E at? Is E not on here? Do I need E? Maybe I don't need E. Let's pretend I don't need E. Huh. So then it's 2,000 to the 5.12 power. Doesn't sound right, but we'll go with it. 2,000 to the 5.12 power. Wait, what? Oh. All right, I'm gonna take the L on this one. I gotta look this up. It should be, let's see, because it's 2,000 times 0.16 would be $320 quarterly. Times that by 4, that's over 1,000. Times that by 8, that's 8,000. It should be something like 13,000 ish. I'm gonna put 13,400. This is wrong. I gotta look that up. I don't know. I don't know. I know it. There's a formula, and I don't remember the formula. Okay, so I gotta write that down. PERT. Oh, I need that though. PERT. All right. So I want to. Oh, this is just. I don't know. Okay, so 2 cars, fuel efficiency, okay. They win a total of 1. So this is a system. So we consumed a total of what we went 1,150 miles. We consumed 35 gallons. So I got to write 2 equations. There's the first car, gallons, and the second car, miles. So it's going to be, if I do miles, yes, it's car 1, so I'll use C plus C2. And that's going to be 35 times G. Okay, so 35 times G, because that's the number of gallons. And then 30 G for the other one. So one car goes 35 miles per gallon, the other one goes 30 miles per gallon. That's how we get that miles. Okay, the second equation is going to be the number of gallons total. So that's 35, and that's going to equal gallons of the first car plus gallons of the second car. So G1 plus G2. I don't think that's right. Man, I'm tripping right now. I got it set up. I just got to solve it. So I got to solve for G. Let's solve for G. But I need 2 equations. I do. I need 2 equations. So we'll use G1, G2. It's not going to be right, though. That's all right. I'm close. but I'm doing something wrong. If I solve for g, I'll get g2 minus 35. If I plug that in, 150 equals 35 times g2 minus 35 plus 30g. Oh no, I want to set them equal to each other. That's what I want to do. 35 g plus. I don't know. So this is a systems problem. I'm tripping right now. I'm making myself look bad. Actually, I'll guess. So it would be, yeah. So it's got to be a total of 35. The other one probably went 30, and the other one, or like, let's see, 20, and the other one 15. I can check it. I'm cheating. This isn't like the real way to do it, but I'm just gonna cheat. I don't want to get this wrong. So 20 times 35 plus 15 times 30. 20 times 35 is 700. No, 700. That's good. Staying the same is good. 15 times 30 is 450. Yeah, so that's what it is. That's the answer. I just got to figure out how to do it right. Okay, I like this one. This is graphing inequalities. You graph it just like you would graph a line, but you have to shade it. That's going to be a dotted line. It's a dotted line. Oh, okay. So graph the line. This is the first equation. I got to make it dotted. Then I ask myself, is 0, 0, where is that? Is it going to make it true? So 0 is less than -5. That's false. So I'm going to shade this side for the first equation. We're going to do this year. So first, so you graph lines, then you graph inequalities. So the second one is +4 is the y-intercept. The shading? Oh, it makes the line dashed. Up 3 over 1, graph the line. This one's going to be solid because it's a closed circle. It's a equal to. Now is 0, 0. Where does this point right here fit? 0 would be greater than or equal to 0 plus 4. So 0 is not greater than 4. So I got to shade this side. So I got to shade this side. So yeah, so I would shade this whole side, but this side doesn't need to be shaded anymore because it's where they overlap. So this is your answer. It's the overlapping ranges, right? Okay, so this is quadratics. We want to find the values of t for which the rocket's height is 93. Yeah. Yep. So this one, I know I need to find, okay, so it's going to be 93 equals 201t minus 16t squared. So this is like a factoring or solving quadratics problem. So it's 93 equals, I don't want to factor that, do I? No, I don't. So I just got to, what do that? You don't want to factor. Oh, I can set up the quadratic formula. So I'll subtract 93 on both sides. I'll get negative 16t squared plus 201t minus 93 equals 0. The a is negative 16, the b is 20, the c is, someone get that. And the quadratic formula is x equals negative b, so negative 20, plus or minus the square root of b squared, so 201 squared, minus 4ac, so times negative 16 plus negative 93, all over 2a, so 2 times negative 16. And that's ugly numbers, but we're going to do it. X equals negative 201 plus or minus the square root. 201 squared. They're trying to kill me. There is another way to do this, but I don't remember it right now. Yeah, I don't remember how to do it off the top of my head. I got 10 minutes. I got to get this done. I'm probably at least 70% right now. So 40,441 minus -4. So it's 3 negatives, so the answer will be positive. So 4 times 16 times 93. So 5,952. All divided by 2 times negative 16 is negative 32. So now I got to solve this using the quadratic formula. So x will equal negative 201 plus or minus the square root of that minus 405. 3401, but positive. This is the inverse. So positive 34,449. The square root of that is, oh, get that negative out of there. That won't work. Can't take the square root of a negative number. 185.6. So x equals negative 201 plus or minus 185.6 divided by negative 32. At this point, I will split it. So I'll get x equals negative 201 plus 185.6 divided by 32. And x equals negative 201 minus 185.6 divided by negative 32 to get my two different answers because it's a quadratic. And I get negative 201. Negative 201 plus 185.6, negative 15.4. Negative 15.4 divided by negative 32 is a positive almost 1/2. Negative 32, so 0.48, because I'm rounding to the hundredth. So 0.48 is one answer. And then 201 minus 1856 is the same as adding, but making them negative. So I'm going to do that. So this number is 386.6 divided by 32, negative 32. Knowing that these are both negative, I get 12.08. Those are my two answers. So 0.48 seconds and 12.08 seconds. So 0.48 or 12.08 seconds. That is when the rocket will reach that height, because rockets obviously fly up and then come back down. We're halfway done. Okay. This is a quadratic. This will be messy because 45 is a big number. So there is a way to get vertex, and I think it's negative c over b. I can't remember. So we're just going to do function notation. We're going to plug in 0, negative 1, and 1. So negative 1, 0, and 1. Negative 1 would be 1 squared is 1 plus 14 times negative 1 is negative 14 plus 45. That is negative 13 plus 45 is 32. I cannot fit 32. I got to try a different number. So 0 won't work either. 1 won't work either. What about 3? Let's try negative 3. Negative 3 would be 9. Negative 3 times 42 is negative 42 plus 45. That's negative 31 plus 45. I still can't fit that on the graph. Come on now. All right, so if we'll try 4. We'll try negative 4. So 16. 14 times 4 is 56, negative 56 plus 45. That's negative 40 plus 45. Okay, that's a 5. So at negative 4, we get a positive 5. We then can do positive 4. Will be the same. Well, not the same thing necessarily. Yeah, definitely won't be the same thing. This is all going to be on the negative side, because if I put a positive number in, it's going to be way too big. So we'll do negative 5 next. Negative 5 is 25. Minus 70 plus 45 is 20. Wait. That's 0. So at 5 we get 0. Negative 5 we get 0. That means for negative 6 we're going to get negative 84. 36 plus 45. 36 minus... Oh, that would make calculator on this. 36 minus 84, 84 minus 36 is 54, 48. Negative 48 plus 45 is negative 3. So at x is 6, we'll get negative 3. Hope that's the vertex. I really, really do. I'm guessing it's the vertex looking at the pattern. So negative 7 is 49 minus 14 times negative 7. That's negative 98. Plus 45. 45 plus 49, that's 94. So negative 4. So negative 7 is negative 4. Okay, this has got to be the vertex. Okay, let's double check because I don't want to get this wrong. But look at the way the curve is breaking. It's got to be the vertex. So negative 8 is 64 minus 112 plus 45. 65 plus 45 would be 110, but it's less than that. It's 109 minus 112, and we get negative 3. Okay, we are in business. So that means it's symmetrical. I can plot this curve now, and we're good. Oh, and the solution, so the x-intercepts are -5 and -9. I almost got that wrong. -5, -9. Those are the x-intercepts. That's what the roots are, the solutions. Whew, getting a workout. Oh, this is easy. So absolute value, you split it. It's w plus 7, positive, and then negative. So negative w plus 7 is greater than 3. Or, wait, do I do it twice here? I don't know if I do. I don't think I do. I'm pretty sure. Oh, yeah, I do. Okay, so we'll do this twice. W plus 7 greater than 3. You get w is greater than -4. And then you get negative w minus 7. You get w is less than -10 because you have to flip the sign. So w is greater than -4 and w is less than -10. Excuse me, guys, I'm not done. I would appreciate it. All right, so this is a compound inequality. We're talking about the range. So this looks like domain and range, right? Yeah, it does. Okay, exponents. This is the J. Cole property. It's the negative reciprocal. So you flip it. So we're going to flip the whole thing and get z -2, z to the -2nd power, 4 z to the 5th on the bottom. We're going to rotate it, 3 on the bottom. And then we're going to drop the z down because it's negative. The z up top. So we get 1 over 4 z to the 7th. You add exponents, all raised to the 3rd power. Raise everything in 3rd power. You get 1 over 64 z to the 21st. Han Soko, 4 and 4. Han Soko, 4 and 4. Hot Cocoa. I think it's Han Soko. They're both like the same thing. Because my name and Han Solo, they're related. So if you think about my name, it makes sense. SOCO, yep. Yep. Milwaukee. You guys got, what, 3 minutes? Is it 1:13 or 1:11? No, what time do we get out of here? So these system of equations, if we try to solve them, they have a solution. They're not exactly the same. And this one also has a solution. Let's solve it. All right, so the bottom one, if you add them, you get 8y equals 8. You get y equals 1. Not too long. And then plug it back into the first equation. We get x plus 4 equals 5. X equals 1. So this one, it's 1, 1. And then the other one, I think we should multiply the first one by -1. And we get -5x plus y equals 1. Let's add them together. We get -10x plus 2y equals 2. Maybe we can't solve this because we're going to get zeros either way. We're going to zero out no matter what we do. We got to cancel one out, and I can't. So I'm just going to say, if you can't cancel out anything, that means that they have infinitely many? Can't remember off the top of my head. Equally steep, they have the same slope, it's 1. Higher point, because it has a y-intercept. This one, the graph is less steep. This one is at the same point. Alright, I'm going to have to stop this video in a second, but I will definitely get the clip of when I get my score. Let's stop this. Oh, I can pause it. I'll pause it. Alright, I'm back. So flying against the wind, an airplane travels a certain distance in time, okay? So 5,670 over 9 hours. And then if I'm flying with the wind, the same plane travels this much less time. So it's similar distance, but different times. So this is a rate of change problem. What is the rate of the plane in still air, and what is it in the wind? So all you gotta do is take the distance and divide. So 5,670 divided by 9 should be something like 650 miles an hour range. What is this? Okay. So 5,670 divided by 9. You see Alex trying to trick me because it's got a rate of 1. Why can't I close this? Let's see. Can I just press enter? 630. So with the wind, 630 kilometers per hour. And the other one is 5,580 divided by 6. 930 kilometers per hour. So good problem would be to convert that to miles per hour because we don't really talk about kilometers per hour. I think I might have got that wrong because I wasn't paying attention. Oh, that's gonna suck if I gotta redo that because I think I misread. All right, so distance after time, it's a function. Ooh, it's an inverse of the function. So how do you do inverses? Inverses, you flip around the output and the input. So, if we're walking distance over time, then it'll be the amount of time as your walking distance. I think it's this one. Or, I mean, it's reciprocal. Is inverse reciprocal? I don't think it is necessarily. Might be though. Let's go with that. Well, not x. Well, yeah, that would be x. All right. So it'd be 1 over. Let's go with the reciprocal. 1 over 10.4 minus 4t. And then 5/2 would be 1 over 4 times 5.2 is 20.8, so negative 10.4. Not sure about that. Oh, it's an x. Don't feel good about that last playing with stuff because I think I gave away a problem. Exponential functions. Exponential functions increase quickly. This is function notation, so I have to make a table. -2, -1, 0, 1, and 2. Raising fractions to exponents means you have to raise both numbers to that power. It's going to have some J. Cole property, negative reciprocal. If I start with 0, anything to the 0 power is 1. Anything to the first power is that number, so that's 4/5. If I raise this to the second power, it's going to be 16 over 25. If I do the -1 power, I got to flip it, so it'll be 5 over 4 raised to the first power, which is 5 over 4. And then to the second power, flip it, and it's going to be 25 over 16. That's interesting. That doesn't necessarily seem right, though. Oh, no, yeah, it does. I got to plot them. So we get -2 to the 25 over. Ooh, why do I got these ugly numbers, though? So 0 is 1. 1 is 4/5. So it's. Wait, what? No, if I raise that, that's 16 over 25. So plot the points on the graph with x values. I don't think I can. Can I zoom? Oh. I had never seen that tool before. So 1 4/5. 2 16 over 25. -1 5/4. -2 25 over 16. Those are our points plotted. Oh, I gotta draw the asymptote. The asymptote will be right here. Because we're never actually going to touch it. Well, is that true? No, it's going to keep getting lower, right? Yeah, asymptote will be here. 0. All right, I'm cool with that. Asymptote means they'll get very, very, very close, but never actually touch it. Almost done. Arithmetic sequence, this is decreasing by 6. So the common difference is -6. It's n minus 6. So the first term is 24. So it'll be 24 plus -6 times n minus 1. If I test that to make sure, if it was 1, 0. If I get 2 in there, it'd be 24. Yeah. 24 minus 6 times n minus 1. There's a couple ways to write that, but now you see it. That was a great one. It's not. It's not working. That's the point. If Michael's reading off his phone, he's not working. All right, so we solve for y. So we get 3y. And then you're going to go right back to it, Michael. You're smart. Abadabada. All right, so I get y is less than 2 minus 4/3 x. So plot the y-intercept is 2. Negative slope, go down 4 to the right 3. Make my line. This is a negative slope. It's an open circle, so I'm going to get a dotted line. And then I ask myself, does 0, 0 make this true? So 0 in for x, 0 in for y. Does 0 greater than 6? No, it's false. So it means I got to shade over here. Bam. All right, so we have another system here. It's the quadratic and the linear system. So we got to find the solution. So the first step is to graph these, and I'll graph the linear equation first because it's going to be easier. It has a y-intercept of 0 and a slope of -2, so I go down 2 over 1. Graph the line. Nice and easy. Now this quadratic function has a y-intercept of -4. I know that because if I put 0 in for x, I'll get a -4. If I put a 1 in, I get 1 squared is 1 times 2 is 2. So 2 minus 4 is -2. So bam, that's my point. And symmetrical graph my parabola. Oh, I got 2 solutions. I got a solution at, what's that? 1, -2, and -2, 4. 1, -2, and -2. 2 solutions intersect twice. All right, draining an aquarium. I like these problems. They're not the most practical, but they make sense. Domain and range. Oh, I love domain and range. So domain. So x is going to be in between 0 and 30. So we'll start with 0 because that's the lowest value. It's going to touch it, so we'll use this one. X, we trap it, 30. Chinese finger trap. X will never be less than 0. It'll touch 0. It'll never be greater than 30. It'll touch 30. The y will go from 0 to 30, 75. So I'll start at 0. It'll also touch, so I'll use it'll equal to y equal to 75. Solve for x. Oh, this is I believe this is logarithmic. You take the log. I don't remember exactly how to do this one. Is there another way? Is there another way to get rid of that base? You can't divide it or anything like that. I'm pretty sure it's a log. If it's a log, it's log of 16, and then is that e? I don't know. I'm not gonna even try. I don't know how to do that one. Forgot. Rocket straight up. Time and height. So it looks like it reaches maximum at 4.6. the average rate of change from 0 to 2.3. So this is a slope type problem. You have 92 minus 0 divided by 2.3 minus 0. You get 92 over 2.3. And we'll see how quickly it accelerated. 92 divided by 2.3, 40. So about 40 meters per second for the first 2.3 seconds. From 4.6 to 11, so it's going down. So it's going to be 0 minus 138 divided by 11.5 minus 4.6. So it's got to be a negative slope. So it's going to be 138 divided by, so 11.5 minus 4.6 is 6.9. It's 138 divided by 6.9. I got to remember that it's negative, so I get 20. So decreasing 20 meters per second for the second half. That goes back down to the ground. Last problem. Use the graph of the function to find the average rate of change from x is negative 4 to x is 2. So if I look at it, x is negative 4 is here. X is 2 is here. So it goes to its maximum at 4. So let's see, 2 comma 4 and negative 4, negative 8. If I do what I just did, I did 4 plus 8 because minus negative, and 2 plus 4 is 6. So 12 divided by 6 is 2. So it should be 2. I don't remember doing a problem before. Let's see what I do. I think I did all right. Look at that. Look at that pi. Mine. It took me, let's see, it took me 36 minutes. Yeah. This was my initial knowledge check. Except for, I know I got one, I got 2 wrong for sure. Because one I forgot how to do and one I messed up. Yeah. 89%. I got to make an avatar now. At least, probably more than that. So let's see. I messed up in, let's see, 89. So I got all my whole numbers, all my fractions, all my decimals. Oh, I missed a couple in real numbers. Curious what those are. Let's check equations. Almost all my equations, little bit inequalities, little bit in functions, little bit in systems. I want to know what that one with the logarithmic one was. That's the one I'm still kicking myself on. And then the lone one, I know I messed up. So hopefully I can get you guys to this 89%, feeling good, knowing some math by the time we finish. Let's check it. Let's take a look. Okay. Let's start my path and see, because I want to find those problems that I messed up. Let's see if they're in here. None of those. A lot of stats stuff. I'm not a big fan of that stuff. None of those. This one. I think I messed that one up. The finding the roots. This one. This is the one I messed up. Let's take a look. The one. So yeah, so the formula 1 plus r over n to the nt. So I forgot about that. I was doing the PERT, which is different. Okay. So I feel good about that. All right. So I'm gonna check out that 89%, 546 topics is looking good. I'm feeling good. I know some math. Let's get you guys there too. Mr. Hanson 404 out.